Why are Ancilla qubits essential for quantum error correction? Imagine trying to fix a delicate piece of art without touching it directly. That's similar to what happens in quantum computers when we try to detect errors in quantum information. Instead of measuring the main data qubits directly, which would ruin their quantum state, we use extra qubits called Ancilla qubits. These Ancilla qubits act like messengers, gathering error information without disturbing the fragile data. They are vital because directly measuring data qubits would collapse their quantum states and erase the information stored inside. Instead, Ancilla qubits interact with data qubits through controlled operations like CNOT gates, which entangle them temporarily. After this interaction, measuring the Ancilla qubits reveals error patterns, called syndromes, that tell us what kind of errors might have occurred. This process allows us to correct errors without destroying the quantum information. Ancilla qubits are prepared in known states, usually called zero states, before each error detection cycle. After they interact with data qubits, measuring them gives us the error syndrome. We then use this information to apply the right correction, restoring the original quantum state. Once the measurement is done, Ancilla qubits are reset to their initial state so they can be used again in ongoing error correction routines. They act as a clean interface between the quantum data and the classical systems that process error information. In practical quantum hardware, Ancilla qubits are used in many error correction codes like the surface code or the shear code. For example, in surface codes, data and Ancilla qubits are arranged in a two-dimensional grid. Each Ancilla interacts only with neighboring data qubits, making error detection more manageable. This layout simplifies hardware design but requires many Ancilla qubits, which increases the overall hardware size and complexity. Without Ancilla qubits, it would be impossible to detect errors reliably, making fault-tolerant quantum computing impossible. In summary, Ancilla qubits are essential because they let us detect errors indirectly, keeping the quantum information safe. They enable us to identify and fix errors without destroying the data, which is key to building reliable, scalable quantum computers. Their role is fundamental in making quantum error correction work, ensuring that fragile quantum states can be maintained long enough for meaningful calculations.